Greetings, everybody. My name is Alin Kurchat. I'm a developer at MultiversX working on the Rust framework and smart contracts. And today I plan to take you on a hands-on approach and get right away into coding a MultiversX smart contract. If you are relatively new to smart contract development, please also check our course on cryptozombies.io and learn how to code the CryptoZombie smart contract by taking a more step-by-step approach. Also, don't forget to check our documentation from anything from a small curiosity to advanced explanations about building smart contract, data types, ABI, interaction with the smart contract, blockchain testing, and so on. Before we can actually start writing some Rust code, one of the first elements that we need to mention is our universal smart contract management tool called MultiversX SC Meta, or SC Meta, how you will call it from the terminal. It's not only a standalone element that allows you to create a new contract in terminal from wherever you want, but also attaches itself to the contract, giving you the possibility to build it or test it. Without further ado, let's actually open the terminal and SC Meta minus null. We're going to start from scratch, so I'm going just as a template empty. I'm going to have an empty contract and name it Crypto Zombies. There we go. And we're fast. And now we can just open it with Visual Studio Code. And here it is, our Rust project and the contract inside the source code. Yeah. One of the elements that you will see a lot in our framework is that the Rust syntax is enhanced with a couple of macros, annotations that transform simple Rust syntax into smart contract elements, such as MultiversX Contract, transform the CryptoZombie straight into the actual contract, and the init, which defines this function init as what is called after deploying the contract. We would like to make a contract in which we interact with zombies, the zombie being the central element of it, and each zombie being defined by a DNA. Let's do one of the first things to actually define what will be the length of this DNA, the identifier of the zombies. We need to create a storage mapper. The reason why we are creating this mapper is because here's the place where we want to save our data. We're going to call it DNA digits. Going to give it as parameter self so that it has access to everything that the contract has, and it will return a single value mapper, and the data type that it will be storing this mapper will be a new8. That I think that will be enough in order to define how long will be digit array that will define the DNA. And inside the init, we will say that sub.dna digits dot set. Well, yeah, the limit first. And we will set the number of digits to 16. The name of the storage mapper needs to be with brackets. The reason why I'm actually making this name with camel case and not keep it as snake case as the name of the function is because this one will be visible on the blockchain, and not only also in our scenarios, we will interact with it. And yeah, we're using the different standard for it. Great. Now that we know how long will be the DNA as array of digits, let's actually create this structure zombie, and it will contain firstly the DNA that we talked about. I think U64 will be actually enough for storing an array of digits, and we will have a name for the zombie. Here, all of us probably will think about the string. Well, in MultiversX, certain data types such as strings or arrays have a small issue. Every time these elements are dynamically alloked on heap. That means every time they are asking for more and more memory from the VM. This might cause on the blockchain increased gas costs or even failures. In order to solve this element, we defined inside our framework some manage types, which what they actually do, they keep the element stored inside the VM, and what you have in contract is nothing but a handle as a U32 index. Make sure to check our documentation if you want to read more about this element. And also here on the dynamic allocation problem, you can find a table with every single unmanaged type and what is the managed counterpart that you can use inside the contracts. Okay, so here in our case, we wanted a string. The best thing to use would be a managed buffer. And because being type defined by us, it will have also some restrictions, which we will place them by adding a generic element, a generic argument, and also putting it on the struct and saying that this M is actually managed type. Yeah. One of the last elements that we need to do for this. Most of the Rust data types that don't have this dynamic allocation problem, they have their own encoding and decoding, for building the contract into WebAssembly, and after that, giving it to the VM. The mesh types don't have straight up away this element, but they have a couple of implementations on the data types that we defined, and every single custom data type that we add needs to have a couple of derives, which just add the implementation from a macro to this new data type that we have. Nested code, nested code, decode, encode, and type API. Yeah, we don't need actually this. And what we need for this to work will be to add as an import MultiversX SC, derived imports, and done. There we go. Now, let's make a way to store our zombie inside a contract. What I was thinking of is that we can have another mapper, just like the one that we did for digits, but indexed, so that every single zombie will be indexed under an element, a small number. We'll give it also maybe the order in which it was created. That means we will need to create two more mappers, one to store a counter for each created zombie, a counter for the last created zombie, and the actual mapper that stores the zombies. I can actually do this. And now we'll call it zombie last index. And the index, we will make it of type usize. And we will have another mapper called zombies. Which will have this ID, the index. And we'll store a zombie inside of it. Because we are inside the contract and the contract being already aware of manage types, here we don't need to give it the manage type API, but we can just give it the API of the contract. That's self API. Great. We're storing the zombie right now, but let's actually create it. Create zombie. We'll give it a name. And as you remember, we're not using a string, we're using managed buffer. We don't need to specify here the API because managed buffer being an element from the framework, it already recognizes it. And the DNA, which is U64. Just maybe to answer a question that probably many of you have it right now. When do I need to specify self API and when I don't? Manage type is defined inside the framework. That means our contract knows about it already. Zombie is a custom type, a custom manage type defined by us, which contains a managed buffer. So every time I'm specifying it inside the contract being defined by me, I need to add it also the self API. I hope that answers your question. Okay. Now we've created our create zombie function. Here, what we will do, we will increase the zombie last index and give the previous last index to the new zombie. That means we also need to have initialized this zombie last index. We can do it inside the init as well. Set usize. And here we will just update the value of zombie last index, self dot zombie last index dot update. Update will require lambda. That's the equivalent of a function that gives us access to what it stores. That means the ID, the usize ID. And over here, we'll basically just access the zombie. So self.zombies.id.set. We will set here a new zombie that we will create. Following that, to just increase our ID. ID plus equal 1. And our new zombie, let zombie equals name and the and we'll just give this not one yields. Oh, and we also need to dereference the ID. Yeah. The reason why we need to dereference is because update gives us access to ID as a mutable reference. And in order to increase its values because of the operation, we need to access the actual value. We cannot access it by reference. There we go. Now that we are creating our zombie, I think it wouldn't be maybe such a good idea to give access to people to just complicate it with a DNA, but rather the DNA to be something random generated. That means we will not make this create zombie as a public endpoint for everyone to have access to it, but rather we would like to have something to generate a new random DNA. So let's make a function generate random DNA. So if it gets access to self, and it will return a new DNA, which our DNA we decided to be an EU64. Now, randomizing the blockchain environment is a challenging task to accomplish. Due to the nature of the environment, nodes must all have the same random generation to be able to reach consensus. But for us, this is easily solved by using Golan's standard seeded random number generated direct in the VM. Without too many details, we can simply just define a new variable of type randomness source. My random equals oh. And in order to use it, we actually need to make it mutable. Mutable, that's because every single moment when we return a random number, the next available number will be stored somewhere inside of it. Over here, we will need to know what is the range of the number that we want to create. We know that, okay, it needs to be greater than 0. That's the easy part. The biggest one, the other, but on the other side, it should be less than the biggest number with 16 digits. So we can, in order to accomplish that, let's actually get the number of the digits from our mapper. Let DNA digits equals cell.DNA digits get. This is how you get from a mapper. And our max value which is actually max value plus 1, should be 10 to the power of the number of DNA digits. Use 64 and DNA digits. Okay, let's see what's wrong. Okay, he wants DNA digits as a U38. We'll make a small conversion over here as U38. There we go. My random Next, U64 in range. Minimum it's 0U64, and the max will be our new max DNA value. One thing about functions is that one way you can return a value is, but the classical return the element and the delimiter, or in Rust, if you know, you can just leave the element that you want to return without the delimiter at the end, and this will automatically return it. It's one way in which you can simplify a bit your code. And now that we have our random generator, we can actually create an endpoint. Now let's call it create random zombie. And we will give the user just the option to define to give it a name. Which will be of type managed buffer, as we learned by now. Doesn't return anything because it's just creates a zombie. We will generate DNA with our generate function that we defined earlier. And after that, all we have left to do is self create zombie name and DNA. Init. Maybe we want to actually see how this random DNA generator works. If we do so, we can define this as a view. Now, you might ask me what would be the difference between a view and an endpoint. Well, the endpoint changes elements inside the contract. View, you can view it as you can see it as a view-only endpoint. One last element that we would like to do in this first part of the smart contract development would be to create an event. An event is an element in which our apps that are listening to our contract on the blockchain might intercept, might get in order to launch certain events inside of them. So if you're listening to the smart contract and, for example, a zombie was just created, you're notified in the app, and the app would do something like, I don't know, pop up a message like, congratulations, you got a new zombie or something like that. So let's create our first event. We'll define it as event. New zombie event. And this would look somewhere similar more to the storage mapper. It's a function without an implementation because everything is done in the framework. And we would like to know what zombie was created. We will be interested probably in the zombie ID, which is a type of view size, the name of it, manage buffer, and the DNA, which is U64. Now, one thing about events is that the parameters, you can also have them indexed. You can have maximum of one parameter which is not indexed. So in our case, I say that we index the zombie ID and we index the DNA. And after we created our event, we need to launch it in the moment when a new zombie was created. That would be here in create zombie. Preferably somewhere where we have access to all three elements, the ID, the DNA, and the name. I think it will be just here where we change our zombie last index. We will just self dot new zombie event. The zombie ID is the ID. Okay. The name is name. And the DNA is DNA. Yeah, the ID, yeah, we need to dereference it because we borrow it. And the name, because of being managed buffer, probably it will say that it loses ownership here where we create it. So probably here we need to also clone it. Also the ID. Reference and clone. Oh, actually here it also needs an dereference. Nice. Go. And now if we want to check that everything is okay, we can just SC Meta all build to build our contract. It can Meta build. There we go. It might take a small while. And if everything goes through, that means our contract is perfectly valid and it will also get built inside the output folder. Usually this takes so. And there we go. In the output, this is the ABI. You can also view it. And soon we'll also get the WASM file, exactly the one that we need in order to deploy this contract. There it is. This is the WASM file. If you have the certain tools, you also can inspect it. And this is what you will use in order to deploy on the blockchain. So that was it for the first part of our smart contract development. Stay tuned for the next part where we will talk about some advanced smart contract concepts and also create a battle system for the zombies. See you soon.